Nice to meet you.
It's gonna be blowing 20, but it's okay. I'll take it.
Okay, our next presentation is going to be on approach panels. And we have Raymond Sear, I think I pronounced the last name correct, from the bridge office, who's with the standards unit. And just looking at the first slide here, this has changed, so you guys get the new and improved version. So anyway, with that, Ray, you can explain your experience a little bit more of where your background has been, how long you've been at the bridge office.
Sure. Yeah.
With that, we will do, and I'll pass this around so that these here. Start the sign up sheet going.
So yeah, I'm Brandon Stewart for the bridge office. I've been there 12 years now. So I did the graduation program. So I was an inspector on a bridge project for a year. And, that was really good time. Really appreciate the work all you guys do in the trenches based on the front line. So thank you in advance for what you do. And so right now, my current role is I'm the bridge standards and research engineer at the bridge office. So approach panel standards are kind of under my name here. So if you guys have questions in the field on the approach panel standards, please reach out to me. If something's unclear, I can always come in and edit, the standards as see fit. So I can't claim credit for all the fancy things in this presentation. So I had our friends at O&E Consulting. They helped us develop the approach panel standards, and also a lot of this PowerPoint was also by them. So I did not create this figure, unfortunately, and can't claim the credit. So now we'll go ahead and get started. So approach panels, most of you probably know what they are, but just have the slide just in case. So, in blue we've got our bridge here, and out here we've got our roadway, maybe bituminous shoulder or concrete shoulder. So there's the roadway, there's the bridge, and then the approach panel is what's indicated in yellow. That's basically the interface between the roadway and the bridge on your project. And there's multiple reasons why we have these. They serve multiple purposes. I'll get into that, but that's a top-down view of what they are, where they're located. And here's an elevation view of them as well. You guys are probably familiar with this as well from our standards. So again, we got our bridge here, and over here's the roadway, and in between there, that interface is the approach panel here. This little red part, I'll talk more about this later, but this is the sill. You probably know what those are as well, but basically kind of helps support the approach panel and the roadway interface. So when I refer to sill, that's the location I'm talking about. So the outline of today's presentation is really the functions that approach panels serve us, and also kind of the development of the new standard plans. So I'm guessing this upcoming construction season, you guys will start to see the new standard plans in use, hopefully. So we're excited about them. Hopefully I can walk you guys through and answer any questions you have on these new standards. So I'll be describing them in pretty significant detail. There's been 19 new/provided sheets. And then I'll talk about some of the constructability, of them, and then also I think there's some review questions at the end that you guys typically use, so I'll do those there as well. Yeah. So the approach panel functions, they carry vehicular traffic from the roadway pavement section of the bridge. We want to try to minimize that bump at the end of the bridges that you might experience. So that's what that interface is really trying to do. They also act to carry the drainage off the bridge and then even further out onto the roadway so that we're not pooling water on the bridge at all. Oftentimes they'll have joints and they can help accommodate any thermal movements between the roadway and the bridge interface. They're also designed to structurally support the barriers and parapets beyond the bridge, which are often required for crash safety. And as I mentioned, they provide the interface between the bridge and the roadway, also for sidewalks and medians. So just diving into each of these purposes in further detail, they carry vehicular traffic from the roadway pavement section to the bridge. And so really there's no custom reinforcement design required. You guys should see a lot of similar reinforcement on other projects. The concrete section and the reinforcement itself is already prescribed in our standard plans. I'll note that the new standards do have slightly beefier reinforcement than the previous standards. You'll start to notice that as these new standards get rolled out on projects. And so we really designed them, there's a potential that there might be a small void, as kind of indicated here, potentially from settlements or whatever, erosion potentially, where we need that approach panel to resist that small void. So we assume that they carry those loads over that small settlement next to the back wall. So in order to minimize the bump at the end of the bridges, basically the bridge over here is often supported on piling, so it's a very rigid vertical interface that really isn't going to move vertically over time, versus over here at the roadway interface, it's just supported on the sill and then the soil below it. So this could move up and down from consolidation, really will go down from consolidation over time from the soil, but then up and down with seasonal changes, frost heave, etc. So this, the roadway approach panel interface moves up and down vertically versus the bridge is pretty much fixed vertically. So you can imagine, if we didn't have this approach panel, you might have a pretty significant bump, and that's what we're trying to minimize that bump by increasing this length of approach panel. Just smooth out that transition. Another function that they do is they carry the drainage off the bridge and onto the roadway and the roadway's drainage system. So we have some drainage here, and it basically goes over the joints of the bridge. Those joints I know they leak often and tear often, but the hope is that they would convey drainage off the bridge over those joints. And then once they get on the approach panel, we have the barrier and the curb sections that ensure that the drainage can continue on the approach panel. And then when you get to the sill, if there's a joint there, the joint is meant to also convey that drainage beyond the sill onto the roadway system and then onto a drainage system. Hopefully it doesn't look quite like this, but I'll keep my picture. And I won't go too much over this, but a big function that they serve is to minimize the effects of bridge thermal expansion and contraction on the adjacent roadway section. So basically, cold temperatures cause concrete to want to shrink. So that's what happens to the bridge. It wants to shrink. And then conversely, hot temperatures will cause the bridge to expand thermally, longitudinally. So basically, the bridge wants to expand and contract based on the temperatures that it's experiencing. And oftentimes the approach panels are tied directly to the bridge, and so those thermal expansions and contractions want to push out the end of this approach panel here as well, and that's why we will provide these sill joints at the end of the approach panels. Really, we don't want the bridge to be moving left and right and bumping into the roadway section itself, so that's the purpose of these sill joints here. I'll also note that longer bridges will typically have larger thermal movements, so you might see larger joints potentially for those cases. So I talked about the bridge expanding and contracting and how that would affect the road. We also assume that there's some contribution of the roadway wanting to impact the approach panel as well, so there is some movement. I will note that the approach panels are concrete. They're always concrete, and so if you have bituminous pavement, that's relatively soft compared to concrete, so we assume that's not really pushing at the sill joint. But when you do have concrete pavement, there is a chance that that concrete pavement would be pushing up against the approach panel, and that will affect the sill joint movement as well. So what we do to accommodate that, so if you have a concrete roadway, you should be seeing references hopefully to this 235, sheet 1 of 2 or sheet 2 of 2 details. You might be more familiar with this one potentially, where basically the concrete panel for the roadway adjacent to the approach panel should have these lugs there, and that's really, those lugs are intended to reduce the amount of expansion and contraction that the adjacent roadway, the concrete roadway, would be inducing on their approach panels. these smaller lugs are present when you have grades less than 4%. And this detail used to be in the approach panel plans, now it's no longer there, it's on 235, so you'll have to go find it there. And then if you have a grade exceeding 4%, we need a little bit more of a hefty lug, I'll call it, so that's what's kind of shown over here. So if you go to 235, it's either sheet 1 or sheet 2, depending on the grade of your roadway. Those should be present if you have a concrete roadway adjacent to your approach panel. So not every project's going to have the same sill or joint type. That's kind of new with our new standards here. So there's three different options for the joint size. There's the E8 that you're probably familiar with. It's typically about 4 inches wide. And then this newer one is this E5 joint, which is 2.5 inch. It accommodates a 2.5 inch opening. And then we also have a joint type called none, where it actually has, there's no joint actually there. It's more just a cold joint, if you will. So I will say the nomenclature is kind of weird. Basically, if you divide the number by 2, you get the size of the joint. So E8 divided by 2 would be 4 inches, and then E5 over 2 is about 2.5 inches. I'm not sure why that was decided upon, but that's the nomenclature that we go with. So that's the joint types. There's 3 different types, and then the sill types is also 3 different types, and I'll talk a lot about this later on. But they're called types A, B, or C. And then really the sill and joint types are both going to depend on the adjacent roadway material, the abutment type, and the expansion length. So these should all be dictated in the front sheet of the approach panel plans. So you guys don't have to be figuring this out, but the engineers should be figuring out what joint size is required, what sill type, and indicating that on the plans. Another function that they do is they structurally support barriers and parapets, so we need some sort of approach barrier and curb, as shown here on the approach panels. So we need to make sure that reinforcement is adequate for a collision, and then also we'll often have this guardrail attachment going off the bridge. And this is a nice photo too. It shows the joint here. I know obviously there's some foliage growing in there as well. They're not perfect, but also it shows the drainage and how that is an important factor of these. Alright, another function to do is it provides an interface for the sidewalks and medians. You can see here, there's a sidewalk on an approach panel. It's got this cover plate leading up to a bituminous sidewalk in this instance. So anyway, they serve all sorts of functions. They're important, so hopefully they're on the projects. So we went through the last couple of years and we developed these new standard plans. It was a pretty large effort. There's a large interdisciplinary group involved with this. They included district road design, district construction, maintenance, foundations, the concrete unit, CO standards, bridge office, and a consultant designer named O&E that helped with this presentation. So a lot of folks were helping us provide the best details that we could get. There's always room for improvement, so like I said, if you guys find things along the way that you think could be better, please reach out to me. Let's see, so we also included some larger layouts and improved details provided. So I think when you had the plan previously, it was kind of, had to squint a little bit to see things. So hopefully this new methodology is going to be enhancing your work as well. We simplified the bill of reinforcement for our low speed bridges. And now if there's a large skew, oftentimes the bridge designer is actually going to have to design that reinforcement and certify that plan sheet. Basically, there's a large skew or complex geometry. But otherwise, it's probably, most of the projects should have pretty similar or non-unique reinforcement detailing for it. So if you go in April 16th of 2024, if you go to the standard plans website, I know it's hard to see, but basically there's a batch of approach panel plans that are now active. Those are the active standards. So like I mentioned a few times, you should be seeing these on future projects. And I'll kind of walk through the standards here. So the new standard figures are 297.223 through 228. I will note that we kind of revamped the nomenclature for these standards, so don't expect that what was on 223 previously is now on 223 currently. It's kind of, things were shifted around, and I even mentioned here this 222 detail was archived. So just note the new standard figure numbers are not going to match the previous numbers that you might be more familiar with. So the total of 19 standard figures that we came up with, and only 8 to 10 sheets of those will probably be used on a typical bridge. It's not going to be all of them, so the roadway designers have to go in and select which ones are appropriate, and they should be listing that for you guys, so you guys know which ones are appropriate to your project. So like I said, they're going to be assembling those and placing the approach panel plans. We'll distribute the grading plans. I kind of fought for this, but then we didn't really get consensus. So a lot of the projects will have plan sheets AP1 through APX as the plan sheet number. So it's kind of the approach panel plans are going to be their own little packet in there. I was told that some larger projects, they might prefer to just have them numbered with the rest of the sheets. So they might not be a separate AP section of the plan. So just, I guess, it could be either way, unfortunately. So some of the sheets aren't going to be certified. Some of them will have to be certified by the roadway or the bridge designers, but some of them won't be. And so for projects with multiple approach panels, some of these standards will be interwoven for the project, basically meaning one of the standard plans might apply to all of the bridges on the project, or some, or none, or well, hopefully not none. If it's none, then it would be in the plans. But it's kind of a mixed bag here of which ones would apply, and you'll have to follow the guidance in the 223 details that I'll walk through here. So changes now, we have 5 separate layout sheets provided for the various SKUs. So I'll just show one here. So basically we really blew up the figure here, the plan view of showing if this is a 0 to 15 degree SKU left. The roadway designer should go in and use this 223 sheet for their project. And similarly, we have 0 to 15 degree right. I'm showing the approach panels in yellow. And so basically we have left and right. I think we got comments from folks in the field that it was a little confusing to get out there and you have to kind of mirror it or think backwards a little bit. So we're trying to make it easier for you guys to read in the field. Similarly, we have options where if you have excess skew of basically exceeding 15 degrees, we have this separate square up panel. That's what I call it. That's this maroon looking color here. I am a gopher, so I had to do it with my guts here. And then similarly, we have a geometry sheet showing if you have a 15 degree skew right. So basically, the bridge that you're working on should have a skew that's appropriate to your actual project. And my personal favorite is a 0 degree skew. It's all nice and squared up, pretty simplistic. So there's 5 different sheets, and really the roadway designer is going to select one of those for your project. So that's the one that you should be seeing. Hopefully it'll make things a little more clear in the field for you guys. So I just zoomed in on one of them. I picked the small skew to the left here. So as I alluded to, this plan view was enlarged. I know it used to be kind of small, so we enlarged it to aid during construction. We added this transverse view, transverse section view down here. And this is probably the most important addition, is we added these tables. And I know you can't see it, I'll zoom in on the next slide, but basically these tables were added to indicate the expansion joint type for the project, the sill detail, and the abutment types of the project. So, as I mentioned before, if you have multiple bridges on a project, each bridge should have its own unique sheet like this for the geometry, and then this table would be filled out for each bridge unique. So here's the table I was alluding to that I zoomed in on, and the roadway designer is going to go in here and they're going to sign this sheet and they're going to say what sort of expansion joint type they have. So it's an E8, E5, or none. And that we also call them saying what that width is. And then they'll indicate which abutment it applies to. So I'll note you could have potentially an E5 or an E8 joint at, say, the west abutment and a E5 joint at the east abutment. It's very likely. So just because you have one joint on one side doesn't mean it's going to match what's on the other side of your bridge. Similarly, for the sill details, we have 3 different options, A, B, or C. And then there's this dark forest option where you have a type A mainline sill and a type B shoulder. I'll get into that later. And again, you could have one sill detail at one abutment and a different sill detail at another abutment. So it's not always going to be the exact same for the project. And lastly, the abutment type. It's pretty simplistic, but basically they'll specify if you have an integral or semi-integral, a parapet Davidson, or a parapet end block option for that abutment. And again, each abutment might be different, so even for that individual bridge. All right, so the changes, I think we're still the same where the barriers and the wing walls are shown schematically. So this one's showing a flared wing wall. That's not necessarily going to be indicative of what your project is. I'd say look at the bridge plans for your wing wall geometry. We just had to show a wing wall, and so that's how we did it. And then also for the barrier and parapets, we show this end station here. And typically, the roadway designer is not going to go in and modify the actual figure here. They're just going to provide the station. So I'll just say a heads up is if there might be an instance where the end of the barrier actually goes all the way out to the end of the approach panel. And it might just not look like that on here, so just pay attention to the actual station value that they show. All right, so the changes as well, I'm just walking through it again. So here's where we have that separate square up panel. And those used to be required for skews exceeding 10 degrees, but we spoke with maintenance and construction folks, and they were fine going up to 15 degrees for that limit now. And the biggest reason why we have, or how we come up with that limit is we talk with maintenance about their snowplow blades, and we're trying to prevent them from snagging when they come across that joint. So they said, yeah, 15 degrees, anything more than that should have this square panel, so basically their blades won't snag with any of this. And also, providing these square panels means that we are squaring up the end of the approach panel with the adjacent roadway, and that's going to help us have improved joint performance at that interface. So the designer should be making sure of this, but there should be this 15-foot minimum spacing here. Otherwise, typically our approach panel minimum length is 20 foot, measured along the length of the roadway. So here was a new sheet that we added. It's got a lot of isometric views, which I think is helpful in the field, just understanding how this complex geometry actually works out. So we've got some plan views showing it, some elevation views, and then these isometric views. So I think really, hopefully, this will help drive home what that end product is supposed to look like. Typically, this sheet won't require certification, and this is one of those that they might just plug it in one project, and this might apply to multiple or all of the bridges on that project. And there's just going to be one sheet for it, basically. All right, so the next set of sheets is this 224 details, and that is the approach panel reinforcement. So we show the plan view and the sections view here. We do have separate sheets provided for these various SKUs. So one of them is for the 0 degree SKU. We have that shown uniquely, so they should be plugging that into their plans for that project, saying this is my reinforcement. Same thing, we have one of them up to 15 degrees left, which is what's shown here, and then similarly, kind of the mirror image would be up to 15 degrees right SKU. The bill of reinforcement is now automated, so it's a little bit I think I'll zoom in on the next slide, kind of showing what that means. But basically, we don't fill out all the bar marks, we kind of leave it up to the rebar fabricator to come up with that. And similarly, this is, like I mentioned, the reinforcement was kind of beefed up a little bit. So the bottom longitudinal bars were now increased in size from a number 6 bar to a number 7 bar. So again, I'm going to zoom in on this bill of reinforcement here. So for SKUs less than or equal to 15 degrees, it should be automated, meaning you're going to come in and pretty much all the plans will show this, unless there's some unique geometry going on. Where we basically just provided equations for the rebar fabricator to come up with how many bars there are, what length they are, etc. So we've got these equations for them to kind of run through. It's on them to provide the appropriate reinforcement on the project. All right, so 224, this is the approach panel reinforcement for larger SKUs. So sheets 4 through 6 are used for the approaches of the square panels. Again, that's what's kind of showing maroon here, those are the square panels. In these instances, the bill of reinforcement is not automated. Bridge engineers actually have to come in there and fill out this bill of reinforcement because there might be some unique geometries they need to consider. call it segment 1 here, if you're looking at the build reinforcement, and segment 2 is the maroon square up panel here. Similarly, on this 224 detail, we show the C2H-D joint details. Kind of what's shown here. I think you guys already had these previously, but basically just staggering those reinforcement as what's required. And then we show the section here of that joint detail. And as I alluded to, here's the build reinforcement, so it's not filled out currently until the bridge designer goes in and actually fills it out for the number of bars and the length of those bars. So they'll probably typically not do an actual special design. It should be similar size bars that you see in there, but they should be just filling it out. I will say the bottom longitudinal bars in the skewed portion, they increased from number 6 bars to number 8 bars. A lot of this increase of reinforcement was we heard from other states that they were saying that they were having some success with that. So that's really the basis of it. I don't know if we were having major issues, but we did go up in bar size based on some recommendations from other states that we solicited. All right. So the same 224 detail, the reinforcement. We added new details to show that reinforcement based on the abutment types listed on the 223 layout sheet. So that 223 layout sheet, that's the one that the roadway designer is certifying, and they have that table. And so I'm just walking you through how that table applies here. So when you come in and you see that front sheet of the approach panels, and they have the table listing the abutment type, west abutment, east abutment, might be a little bit different, but whatever they select there is the one that you would apply on this 224 detail. Because the 224 detail has all 3 of these options shown, and so you have to refer back to 223 to say, hey, I've got a integral and a semi-integral up here, or else down here we have a end block option where there's a separate end block here versus the parapet with a Davidson joint where there is no separate end block. It's just a whole kind of monolith here. So if you're wondering which one of these applies to the project, flip back to 223. That's where you can find the answer. I'll show some photos of this later on too from the field, but I will note that this bar coming up out of the abutment changed a little bit. It used to come up, and then it would just go horizontally out here. We heard some complaints from the field of basically if we have the bar extending out here from our abutment, they weren't really able to get their compaction equipment out there, and it was kind of a mess. So what we did instead is we hooked to this end up here so that when they're compacting back here, there's not going to be as much conflict. And that's really true for all of these options. So the integral, the semi-integral, the end block, and the Davidson both for the parapets. So we should be seeing that in these new standards. Similarly, this bit felt is at the abutment and the sill. So here and here. I've been asked before why we have that. But really, the reason is due to some vertical loading of there's vehicles out on this approach panel, and that will induce some rotation at these ends. And so what happens is if we have this rotation, if the approach panel wants to rotate, we've got this corner of the sill or corner of the abutment, and I think we all know corners of concrete tend to maybe spall a little bit. So what we do is we provide this bit felt there just to kind of reduce the actual pointed loading at that edge to help reduce spalling. So that's the reason the bit felt is there. It is important. But I've been asked before why we have it. That's the reason. And then polyethylene, that's what I've highlighted in yellow here, is placed below the approach panel, and it also extends, if there's a sill, it'll extend all the way up to the basically the joint at the sill. And the reason we have this, I alluded to earlier, we have these thermal loads from our bridge that's trying to push against the roadway. We actually want to encourage these thermal loads to happen in the approach panel. So we put this polyethylene down here below the entire length of the approach panel so that it can move. And then all of that movement goes up to this joint instead of getting locked up in the approach panel and having adverse effects on our bridge. So that's the reason why we have this polyethylene, is to encourage that movement so that the joint is taking demand and it's not inducing forces we didn't anticipate. All right, then sheet 6 of 224. This one will be included for if you have a square up panel. It's got the same 3 details. It's a little hard to see, I know, but it's got here's the end block, here's the Davidson, and here's the integral or semi-integral detail. And again, refer to 223 to know which one is appropriate for your project. I will note that we don't show lap bars on here. We kind of allude to that as well. So if there is some unique reinforcement required in this transverse view, we're not going to show the laps because we typically don't want them to certify their sheet. They would be certifying instead this sheet. So that's where any laps might be shown, might be on here. But if it's not required, it would not be shown on this transverse section sheet. All right, 225, this is the sill detail sheet. So as I alluded to, there's 3 different sill options, A, B, or C now. Those are all included on here. Here's A, here's B, here's C, and I'll walk through those all in more detail in a bit. And then also, we note that there's different expansion joints. They can be the E8, E5, or none. And those are also kind of shown here as well. And the bill of reinforcement, similar to what we've done in the past for that I just showed you, is automated for the sill in addition to the low skew for both panels. This is a change. So now we have this, so this is a section view, or an elevation view, I guess, of the sill itself. And it used to extend all the way out to the edge of the curb, more or less. And now we've got this 12-inch cantilever of the top of the approach panel and the curb extending beyond where the sill does. So we stop the sill short, and that's really to accommodate for this drainage that I'm kind of showing here. I think that used to interfere with the posts from the 694 standards. And so this way, by providing this 12-inch cantilever, basically, there's a little bit of wiggle room for us to maneuver that drainage away from where those posts would be from the basically the gutter line posts, right? So, sorry, not the guardrail posts. Okay. So again, if you go to 223, that's the very first sheet. It's going to have these tables, and now I'm showing how those impact this 225 detail. So we have the expansion joint type. It can be E8, E5, or none. Same thing, that they'll indicate the sill detail applicable for each end of the bridge on the project. Again, these details might vary by abutment and also by bridge. So just pay attention to that. I'll just note that sills provide support for the end of the approach panel, at the end of the approach panel where it meets the roadway to reduce the differential settlement, and they also provide a base for the E8 or E5 joint. I have it in red because it might show up on that quiz or whatever later I had, but I wouldn't worry about it too much. Okay, so the different sill details, I was going to walk through what they look like and when they're kind of used. So sill option A, that's what I'm showing here on the left. Basically, you've got your approach panel on the left, and then this would be a concrete roadway on the right. So this is used for cases where you have a concrete main line for the roadway, if indicated on the 223 layout sheet table. So it might, if you have sill detail A at both abutments on your bridge, it might look something like this on that front sheet. They're just going to cross out or check off on the list which one applies to the project. So if you see this checked off, then you know sill option A works, and you would use this option as shown on the 225 sheet. So there's drainage that's provided. It's kind of hard to see, I know, but there's right here below the joint, and then also right here, right below the approach panel and adjacent to the sill. You have a separate drainage here as well. And this drainage is important. We just want to prevent any buildup of water below this approach panel to reduce any frost heave or whatever. We want to get that drainage away from underneath our approach panel. So that's why we have these 2 different options here for the sill option. I will say the sill option A is only used if you have an E8 or an E5 expansion joint. We would never really use this for a 0-inch expansion joint or none. And the bill of reinforcement here, it's a little hard to see, but basically we have the same thing where we just provide equations for the number of bars and the length of those bars so that the rebar manufacturer can come in and determine what's appropriate for that project. So, similarly, still option B. This one you can see is a little bit smaller. Typically, this will be used with the E5 joint, and this is cases with a bituminous mainline and shoulders. So that's what's shown on the right here. We get a bituminous roadway. On the left is your approach panel. Here's your sill. And there's this little lug, I call it, so the concrete lug adjacent to the joint and the bituminous roadway interface. And again, on the 220, how do you know if still option B applies to you? You go to that front sheet, 223, and you say still option B. If it's checked off here, then you know that this detail I'm showing here on the left from 225 would apply to your project. So in this case, the concrete sill is still required, and the build reinforcement is automated, similar to what I just showed on the sill option A. Sill option C, this is the kind of the alternative, which is a little bit, there's no sill basically. It says it's a sill option, but there's no sill down here, and there's no joint. So basically this is only for projects where the bridge might be relatively short, and it doesn't have that much thermal expansion, and so it's not pushing too much against the roadway. So if there's a bituminous roadway, we say, you know what, it's actually okay, there's not that much induced forces that we can just have this, I don't know, I call it the cold joint basically, where there's the concrete approach panel ends, and there's the bituminous roadway right next to it. There's no E8 or E5 there, and there's no actual concrete sill. We still do have drainage here. That's because there's this vertical interface where moisture could get down, so we like to have that provided. And we still do have that polyethylene placed underneath the approach panel to encourage the approach panel itself to shift. The reason why we can get away with this is because bituminous is a relatively soft material compared to concrete, and so if the concrete wants to move, it's not going to have a very big adverse effect on the bituminous roadway. Again, how do you know if this is applicable? I know I'm beating this to death a little bit, but you go to 223, the front sheet approach panels, and you say, oh, I got still option C selected here, maybe here too, and that's how you know that you need to use the sill option as provided on the 225 detail. So again, there's no concrete sill provided, no expansion joint. It's a little unnerving, but we've got confidence that it'll work. So. And then here's kind of the dark horse. It's kind of a unique option where if you see this marked up on the front 223 sheet, this is what it means. So basically, if we have sill detail A mainline and B shoulder, what that kind of means is that you've got a concrete mainline, I'm showing that in blue here, and then you have this concrete lug that I kind of alluded to. That's what I'm just showing here now, vertically in the plan view. And then you have these bituminous shoulders and fins. So if that's indicated, that's basically saying that's your circumstance. Concrete mainline, bituminous shoulders, but you still have this concrete lug required all the way along your approach panel, and that's because you're trying to make sure that this expansion joint material can extend all the way out as well. Your approach panel is still going to want to extend or expand and contract how it wants to, and so you need to make sure you're providing adequate expansion for that. So if this is the case, I would say don't be tempted to change joint sizes when you get to the bituminous shoulder or anything. Just have a constant E8 or E5 joint. Whatever's required by the engineer, just make sure that that joint is going all the way along across the bridge here. Don't try to splice an E8 with an E5 because I don't think that's going to perform very well. So this is a new thing that came in. Paul Polarski had requested it, but I alluded earlier that concrete corners don't really perform very well. They tend to spall. So I think he's had a few projects where they've proposed using a 3/4 inch radius edger here. This isn't finalized. This is something that we're looking into. I think we've let some of the contractors know that we're interested in just having this option. So it's not in the standards yet. It probably will be in our upcoming update. Or just stay tuned for that, I guess. It sounds like that's the option that Polarski and those folks would like. So likely that's the way we're headed. All right, 226. So those are the other details. These are all new actually. So I guess these joint details you've seen previously, we just threw those on 226. We're trying to find out where we had room. But if you come in here, we've got isometric views showing all these different instances. This particular sheet, 1 of 3, shows where you've got either the curb and or the barrier extending across the joint. So it kind of just shows, here's your joints, for example, here's the sill, and here's your barrier on the approach panel, and then similarly your barrier on the adjacent roadway, if that's your surface.
Where's you got railing ending and curb starting right at the jump?
Like that?
Yeah, that's
Yep. So that's the separate detail. So they would apply that if it applies to the project. I think actually this is probably more common, right? Where the barrier might not extend all the way across and the curb might not extend, onto the roadway. So this is the case as well. Stole my thunder. No. Okay. So there is this other option I'm showing down here. This is really only for local roads. If local roads might not have the curb transition coming up to it, if it's a low speed, for example, that might be an option. So you might see that if you're on more state aid projects, but typically MnDOT would not have this detail. We would typically, if the barrier ends at the end of the approach panel, it would just transition to this curve I'm showing here. We figured isometric views were helpful just to help visualize what it should look like, and you can compare what's out in the field with what's shown here. And again, these 2 sheets that I just showed, they're not, I mean, we have a plethora of different options. So basically the engineer has to go in and say which one of these applies to my project and, specify those, or basically include those in their plans as needed. But those should be there. So yeah, I think you guys are familiar with these joint details. These used to be on a separate detail, and now they're now on the 226 that I just showed. I just zoomed in on them here. I would say, so here's the actual joint details themselves. I would say go to 297.227 to find the location of these actual joints. Kind of a plan view. I'll show that coming up here. All right, so there's 226 joint details is going to be included on all projects. And these sheets would only be included once in the plan set for the whole project. Those that don't apply might be omitted. And again, refer back to 223, that's going to be your best friend in the field. It's going to have these tables, and those will help you know which one applies to your project. P items, they're a little different, I think, now. So the 2025 spec book, I believe we have this newer 2406.503 expansion joints design E5. That's for the smaller 2.5-inch joints. Used to be a 600 items, so meaning it was in the special provisions. So again, it's just going to be a transition for once these start getting used, but I think the new spec book should have this as a 500 item. And design E8 is a 500 item as well in the spec book. So if you're looking for payment, that's where you go find it. So here's the joint details sheet 3 of 3, and we'll zoom in on some of these. If you don't have a joint, so basically if you had sill option C where there's no joint and no sill, you might not even see the sheet on your project. But if you do have a joint, we show some details of what those should look like, and also the drainage underneath those joints and how that would look. So I zoomed in here. This is we have these now cover plates on the outside of the joint. So here's your curve, and then here's, the adjacent grading or whatever. And we have now this HDPE cover plate, like you'd find at a playground, some of that stuff. So we had some concerns with some galvanized steel plates corroding in these areas, so we replaced it with this HDPE cover plate out there. And I will also note, there's this note here, there's no longer a cover plate required on the front face of the curb. I think that's a difference. There used to be one on the front face of the curb, and now there's just one on the back face of the curb. Okay, so for E8 and E5 joint installation, the concrete surfaces in contact with the seal adhesive must be at least 28 days old prior to installing expansion joint seal. Make sure you're providing the E8 or E5 joints per the MnDOT APL and per those manufacturer recommendations. I'm showing here, this is a kind of an or section view of it, where basically the joint material, at your gutter line should kick up a bit. And then come back down. The reason we have this kick up is really just, we're trying to get the drainage, there's drainage that's going to be basically pooling in the gutter line And if we did have this pickup, the drainage would just come right out the joint. That's not what we want. We want the drainage to continue basically into the page here, so that it gets off of our approach panel onto the roadway section, so that it can go to that drainage basin or wherever they have. So make sure that they have this pickup as shown here. And let's see, yeah, I guess there's cover plates. I'd say refer to the bridge plan for those cover plates, both for the barriers and also for if there's a sidewalk. Those should be in the bridge plans and not necessarily these approach panel plans. All right, the joint layout. So these are the sheets I was alluding to, the C2, H-D joints and etc. Those would be, kind of indicated here where those are located. So I would say use this standard joint layout for really just 2-lane bridges and skews less than or equal to 15 degrees. We have a separate layout when you have a larger skew. That'll show next. And typically these won't be modified by the engineer. There might be instances if you notice that this is probably certified by someone, it probably means that they had to change something from the typical joint layout, so just be aware of that. And then contact the MnDOT concrete unit for questions on these joint layouts. Namely, I think Jake Gabe has been the one expert really to help out with this a lot, so he has contact information. If you don't, just reach out to me and I can forward it to him. The engineer should be coming up with unique joint layouts if they're required, but typically it'll just be this. And then similarly, this is the one with the square up panels. It gets a little bit more dicey here with things. I think, oops, I don't have it there. Sometimes, if the square panel is large enough, Jake has indicated that he might require a joint kind of right here as well, in addition to what's shown. So just keep an eye out for that, especially for these larger skew ones. There might be some more unique joint layouts required. Let's see, drainage layout. So this sheet will be provided once on all projects. We do want the drainage everywhere for all the approach panels. Certification probably not going to be required unless there's something really unique going on in the project. So you're probably just going to see this sheet once and it'll apply to all the different approach panels, all the different bridges, I should say, on that project. So we have this new 2-inch perforated pipe provided on the top of the sills. I was showing that a little bit earlier. Basically, right below that E8 or E5 joint, we've got that perforated pipe. It's a little bit smaller than it used to be, and I think it's because it's within the joint itself, and there's also a separate drainage pipe kind of right by the edge of the sill as well, that I showed you guys earlier. And there used to be catch basin details shown on the actual approach panel sheets themselves. We don't show those now. We do kind of allude to them. They're kind of shown generically out here, but we really just say prefer the roadway plans for those actual catch basin details. We just didn't feel like it was appropriate to have those on the approach panel plans because they're not on the, they shouldn't be on the approach panels. So
whose responsibility is then, if there are drainage structures on the approach panel, to modify the reinforcement to compensate for that?
Sure, yeah.
Would it be the supplier?
No, not the supplier. So if they have those catch basins on the approach panels themselves, the roadway designer would have to reach out to the bridge designer and say, hey, I've got this structure here. I need to figure out how can we make that reinforcement work. So that would be more of a unique reinforcement layout required for that instance.
So are you saying the approach panels are not going to be part of the bridge plan and not the roadway plan?
No, that is. Let me tell you, that is up for debate. That has been up for debate.
I've never seen an approach panel that wasn't right before a bridge.
Yep. I fully understand it. I actually kind of agree with that. But the powers that be, I think it is still a roadway item. Yep. So I'm with you. And it wouldn't help me to have it. It won't be no work for me, but it would make more sense. I agree with you. So next up, I'll talk about construction. And I'll note that some locally funded bridges might not even have approach panels. I don't deal too much with the local side of things. My colleague Dave Conkle will know more about this, but basically, they have kind of their own rules or their own ways of doing things that might not match what we do for trunk highway bridges. And in those instances, a short section of curb and catch bases might be included, kind of adjacent to it. Yeah, the standards are typically shown generically, so I'd refer to grading plans for any project-specific requirements. The concrete mix used for these is should be 3S52. And I'll note that some projects might require a separate wearing course as they see the plans. And to your point, typically if the bridge has a separate wearing course, the approach panels will also have a separate wearing course. It's not always the case, but I think 99% of the time that is. So, oh, there it is right there. And then, let's see, just pour the concrete carefully, don't displace the joint assembly. In terms of the actual construction, just remember there's going to be 2 separate layers, top and bottom layers of perpendicular rebar grid mats used. And that reinforcement is epoxy coated in accordance with Spec 3301, grade 60, ASTM A615. See some black bar out there, like that, I guess. We do want these to be durable products. Protect newly placed concrete from damage by vibratory and backfilling operations for 24 hours. And I said it earlier, but approach panels are typically going to be 20 foot long. We found that that's long enough for that transition from the roadway to the bridge without having a uncomfortable bump for the traveling public, basically. The exception to that is if the skew exceeds 15 degrees, you're going to have typically a 20 foot long skewed portion followed by a longer portion that's square up panel I was showing you guys earlier. And then standard spec 2406 for bridge approach panels. There's a lot more information as well regarding the construction of them. So grading, and I know I'm a little bit tight on time, so I'll try to keep going here. So if you go to the 233 sheet, there should be some grading details for behind parapet or semi-underground abutments. I will note, the bridge plans typically have this drainage B910 detail. Just make sure that that's also provided. We don't want to have a lot of buildup of water behind our abutments. But this will also show the polyethylene, the sill details, etc. But really, I think getting the grading down here is pretty paramount, just because if the sill starts settling a lot, that's when you start to get less of a comfortable ride when you're going over. If this is settling and you can tell this one's on final, it's not going to settle really. So getting good material down here is, I think, pretty important. Similarly for integral abutments, I just showed this 234 detail. Structural backfill back here. Again, this is typically going to be on piling. So just, again, trying to have good quality material below the sill and below the approach panel is important. A few photos from construction, so just showing the polyethylene. So place that directly below the approach panel. That's really going to help us get our thermal expansion that we need, so that we're not reducing stresses into our bridge or the roadway. Hopefully all those stresses are going into that joint, the E8 or E5 joint, the approach panel roadway interface. And then this one, actually, is a good photo, I think. This is showing the old approach panel ties. I was trying to explain it earlier, but basically they would pop out of the abutments, and then they'd have this horizontal leg, and you can tell, if they're trying to get their compaction equipment up, they really can't. When it's adjacent to this. That's why we have now this new detail. We have these hooked bars that really don't extend that far out beyond. So that's why we made that change. So hopefully there's better compaction that we're able to get immediately behind the abutments here. Surface finish, so the roadway surface finish of bridge approach panels, excluding the 1 foot face from each curve basically, shall be given a final texture in accordance with 2401 or 2404 if there's a separate wearing course. The timing for the approach panel should match what's on the bridge, the direction and the style of it. And then there's a surface tolerance of 3/8 of an inch in 10 foot. That's really just, we're trying to make sure we provide positive drainage still, prevent pooling of water on the approach panel. I've seen a lot of approach panels where there's just this pooling of water kind of by the joint, and not ideal, but I understand it does happen. Trying to avoid that if possible. And yeah, the surface of the approach panel should match the surface of the bridge deck. So concrete carrying and protection really is no different from any other concrete carrying and protection. We have a 72-hour minimum cure period, 96 hours if there's any substitutions into the mix. Using an AMS membrane commonly or a blanket cure. And if there's adverse weather, there should be a cold weather protection plan. And then 2406.3H just mentions when you should open the approach panel to public traffic or heavy equipment, I guess. All right, so review questions. If you have the handout, you probably have it, but say, what's the purpose of a sill? Bueller, if you're out there. No? So, provide support. It sounds, yeah, you might have the answers. That's okay. Reduce differential settlement, and also provides a base for E8 or E5. So if you got them, I can not be silly. I'll just go through them. Can a sill be used when there's a bituminous main line? It's kind of a weird question. The answer is yes, it can. Might not have to be though, right? So you have the one here on the left. This is the sill option B. You've got the roadway, sill, and then there's concrete little log. And there's a bituminous roadway. So that's if you have an E5. But if you have a none joint, there might not be a sill. How many grid mats of rebar are in the approach panel? What type of reinforcement is in the approach panel?
Green.
Yeah. Basically, yeah. Which MnDOT spec discusses approach panels? Yep, I heard it. 2406. And approach panels, are generally found in which plan set?
Bridge.
Grading plans. Yep.
And what do grading people know about concrete pavement?
That's where it's this whole mess of they have certain things that, I mean, I'll tell you, my wife is a roadway engineer, so you can imagine the dinner conversations we literally have about approach panels. Who should take ownership of these? And yeah, it's a yeah. So what was your question again? Sorry. Okay. Yeah. If the bridge gets a wearing course, man, this is just feeding into your point here. But if the bridge gets a wearing course, does the approach panel also get a wearing course?
Yes.
Typically, yes. Yep. And generally, how long is approach panel with a low skew? Additional approach panel length? Maybe, yeah, thank you. That's not great, sorry. Additional approach panel length may be required as large skew. Yes. All right, that's all I had. Thank you guys for your attention today. You got my email and my phone number there, so I can run but I can't hide. But any questions or?
I thought the review of the approach panels, they've been bad for a long time.
Yeah.
Yep. Really bad.
Yep.
Nobody wants to add any information on, oh, this one we don't need, this one we don't need, and there you go.
Yep.
Doesn't even match close to what you're doing up there.
Yep. That's where I think when we have our,
A little chart.
we've got those separate figures basically indicating, you know,
Yeah.
this is for this skew. Yeah, so this will actually now be mirrored if you have the opposite skew. And I think that's probably the biggest help, because I think in the field it's probably just really confusing of turning upside down or whatever you had to do to make it make sense. But we have a left and a right skew. And
The only thing I didn't see is though, like sometimes you have the abutment has a ring wall that's part of the structure, you know, that's buried and have barrier, and then the approach panel's kind of in there, but if there's a polystyrene joint there.
yep.
I didn't really see anything like that addressed here, but possible.
I think it's in there.
Okay.
It's right here.
Okay.
I know it's hard to see,
Yeah, okay.
but it's right there. So there is that polystyrene
Okay.
between the wing wall and the approach.
Great, okay.
And that's really just where you've got these parallel wing walls, right? You wouldn't have to have it for a flared wing wall.
Yeah.
For the parallel ones, we're just running along.
I was on bridge for a little bit of that. Had that on one side, but completely different on the other side.
Yep.
On the same end of the bridge.
Anything else? All right, thank you, folks.
Okay, let's take about we'll go 10-minute break, so about 10 minutes too.
I hope this one's better.